Dear listeners, today we are going to discuss some basic theorems of probability. So first of all, we see the conditional probability, and that is probability of A given B. So let's see how we derive the formula for conditional probability. So if I remove P here from here, and we just analyze this equation, let me delete this as well. So if we have to find A given B, what does it mean? It means we are trying to find A given we have already B. So this Venn diagram can explain this notion very well. It says given we have B, so this blue circle actually represents B, and given we have B, we have to find A. So A given B means we are trying to find that A which is shared by this B. So that A should be included in the B because the condition is given we have B. So it means we will A given B is the area actually which is shared between both of them, and we represent this area by A and B are A intersection B, and this shows it is actually ratio of this shared area with total B. So we write B here, and in terms of probability we can write it like this. So this is the formula of conditional probability, which says the probability of A given B is equal to actually the probability of the shared area between the two divided by the probability of the whole area of the B. So this is the basic law of conditional probability. From this we can write it like this, intersection, and from this law we can derive some other formulas as well. Like we can say probability of A and B, which is actually the same as this intersection B, would be equal to probability of, we move this value to this side, so it will be multiplied after going to this side, probability of A given B into probability of B. So this is another formula that we derived from this conditional probability, which says the intersection of A and B is equal to probability of A given B into probability of B. And if I write another formula just like this, if I just swap these value, probability of A and B, B and A, B intersection A, so by using this formula we can write it like this, of B given A into probability of A. Now as you can see that A and B are B and A, they are one and the same thing. So from left side of this equation we can say that equation 1 and equation 2 are same. So if we use the right side of this equation, we get that probability of B given A into probability of A, that is actually equation 2, is equal to probability of A given B into probability of B. So from here we can write it like this. I take this value to the right side, and if we move it to the right side, it will be divided. It will divide the value on the right side. So we got another formula, and this is very important formula, and it is called Bayes' law or Bayes' theorem of probability. This law or this theorem of probability is very important, very and it has applications and many areas of computer science and artificial intelligence, even in biology, even in law, uh, and in medical science, because this formula give us an option to predict about the future from the past. So if we have the probability of A given B, we can find the probability of B given A, and it has many interesting applications. Even some decisions have been made in the court by using this Bayes law or Bayes theorem. We will discuss in detail about this theorem in the next lectures. So right now you just need to learn this formula, and for its application and its detailed examples you have to uh, see my next lectures. So this is Bayes law and this is the law of conditional probability. So next we check some other uh, basic formulas of probability to just to make understand the concept of probability. We have an example. This is a table, and it means this 0.04 means probability of cavity and tooth thick, and this 0.06 means probability of cavity and not tooth thick. Similarly, these two values. So if I ask you what is the probability of cavity and tooth thick, you know the answer is 0.0604, and probability of cavity and not tooth thick, the answer is 0.06. So if I ask the probability of cavity, and for now we are just concerned with the cavity, we are not concerned with tooth thick. We do not care whether there is tooth thick or there is no tooth thick. So in that case we are just concerned with cavity. We will add these both values. So probability of cavity is actually equal to 0.04 plus 0.06, and that is 0.1. So from this table we concluded that probability of cavity is actually equal to, let me decrease this font size, probability of cavity and tooth thick plus probability of cavity and not tooth thick. So I just copy this symbol from here. So this actually equation gives us another important formula, that is how can we compute the total probability of one factor when we have it for two factors. So if we have it for two factors, we will add it with both forms of the second factor. This is a yes form and this is a no form. And next we can represent this equation in some modified way, and that would be if we use the formula that we derived earlier, and that is this formula. Let me copy this formula here and just using this formula we can say that it means it says A and B, probability of A and B is equal to probability of A given B into probability of B. So applying this formula on this value and on this value, we will get probability of cavity given tooth thick into probability of tooth thick plus applying the same formula on this value probability of cavity given not too thick, sorry, into probability of not too thick. So this is another important formula that we will use in next video lectures. So for now, you just have to learn these formulas, and for its applications and examples, you have to watch my next videos. That's it. Thanks for watching.